Each element is different because of its unique number of protons. But what if I told you that there is an atom with no protons, and instead only neutrons? In 1926, the German scientist Andreas von Antropoff named the hypothetical element 0 of the periodic table. It's called neutronium, and its many potential forms may change how we view the periodic table. So what exactly is neutronium? Well, neutronium refers to the materials present in the cores of neutron stars. These stars are the collapsed cores of supergiant stars that have had a supernova explosion. The gravitational pressure at the star's core exceeds the electron degeneracy pressure, and so a special process occurs: electron capture. Electron capture is when the nucleus of an electrically neutral atom absorbs an inner electron. This changes a nuclear proton into a neutron, while also emitting an electron neutrino. The neutrino carries all of the decay energy, meaning that the remaining atom transitions to its ground state. After this process is complete, the atomic number has been reduced by 1, but the mass number does not change because of the new neutron. But electron capture isn't the only way that protons decay into neutrons. If there is a sufficient energy difference between the parent and daughter atoms, then positron emission may occur. This process is very similar to electron capture, with the only difference being that a positron is emitted in addition to an electron neutrino. These two processes allow for protons to be converted into neutrons, and if all protons are converted, then you're left with neutronium, formerly called neutron degenerate matter. Neutronium has many potential forms, starting with an isolated neutron. This neutron undergoes beta decay and has an average lifetime of 15 minutes, decaying back into a proton and an electron, but also emitting an antineutrino. Next is the dineutron, which is not a stable bound particle. While it has been observed in the decay of beryllium-16, it is theorized that the dineutron can be produced by reactions involving either tritium, which is hydrogen-3, or helions, which is ionized helium-3, via neutron emission and electron capture. The trineutron, tetraneutron, and pentaneutron have not been detected, and we are unsure if they are able to be bound. So what purpose does neutronium serve? Well, the French engineer and biologist Charles Genet redesigned the periodic table using neutronium as a focal point. He created the left-step periodic table, according to the rule that he discovered called the correct distribution law. This rule is more commonly known as Madelung's rule, and it states the order in which electrons fill an atom's subshells. Genet's new table was designed so that element 0, which he believed would be the dineutron, would link the left-step table to a mirror image table of elements with negative atomic numbers, or antimatter. He theorized all of this before the neutron was even discovered, as Genet died just 3 months before the neutron's discovery. Perhaps one day neutronium will officially be called element 0, but until then, we can only wonder if Charles Genet's theory was correct. Thanks for watching. Like and subscribe.